To use calculus to solve optimization problems, here's an example. A farmer wants to build 5 pens, all adjacent and the same size. So there are 5 different pig pens, all have to be adjacent. They're all the same size. Since they're adjacent, that means they share a side, so you don't have to have double sides for your fencing. He has 2,000 feet of fencing to work with. So out of that 2,000 feet, he needs 5 equal pens. What are the dimensions of one of the pens, given that he wants to have the most area possible? So here's one pen, and then we keep adding another onto it. There's number 3, and then 4, and then 5. So the figure is going to look like this. And I'm going to make this be X on the bottom side, the whole distance. Now you could make that W, B, Z, whatever you want, but I'm just going to use X. And then Y's are going to be all the way through there, up and down. Common mistakes on these problems when you have things that are adjacent is to miscount how many different variables you have there, or how many that are the same. In this case, there's 1, 2, 3, 4, 5, 6. What would be a common mistake in terms of instead of having 6Y somewhere, what would you have as a mistake? 5Y, because you think there are 5 pins, and therefore there are only 5 different sections that need to be up and down. So what is the total area that we're looking at? So area equals XY. We're not given an area that we're supposed to use, so we come up with a formula XY. And then what is the perimeter of everything? How much fencing does he have? 2,000 feet. So that would be the perimeter, and we have to come up with a formula that would express the perimeter equal to 2,000. And perimeter would be doing this and then following this, noting that you already have this side here, and then back around. So I'll give you a chance to jot that down if you're still going. All right. Is everybody still tagging along? All right. So from there, we're going to see what we can do to find the maximum. All right. So the derivative ends up being 1,000 over 3 minus 2/3 x. Set it equal to 0. And you have 1,000 over 3 minus 2/3 x equals 0. Move to the right, change the sign, and divide by a negative 2/3, which means you multiply by a negative 3/2. And those cancel out. The negative signs do as well. So you should be left with 500 over 2, and that will be 250. So actually this one, I had another problem in mind when I was doing that, so that was actually 500 is what it should be. And it's not going to make too much of a difference. We can make a notation on that as we go through the next slides. 1,000 over 2 is 500. Now over here we have to plug back in what we had so we can solve backwards. Now clearly we're not going to be putting in 250. We're going to have to put in the 500 like we did before. So we're going to mark this one out and put in 500. So that'll give us 1,000 in this spot here. And when we go to subtract, we'll be subtracting 1,000 there. So 6y equals 2,000 minus 1,000. So now to clean up what we had, 6y equals 1,500 should not be right. What should we have on the right side? 1,000, yeah. So we'll divide 1,000 by 6. And clearly that's not going to be 500 over 2. It's going to be 500 over 3. when we divide. And 500 over 3 is not going to be 250. So we'll have 166 and 2/3. We don't want to round it, especially on these problems, because if you start rounding up to 167, you're going to have an extra foot of fence left over, or maybe 2 at the end of it. So 166 and 2/3. Now with x coming out to be 500, that means you have 500 here, and then should be 500 on the top side as well. 500, 500, and then you have to go back and then put in your 166 and 2/3 all the way across there for y. If you multiply this by 6 to double check to account for each of these items that are 166 and 2/3, then you should come out with 1,000. So if all of those added up are 1,000, and this is 5,000, or not 5,000, but 500, and then 500, does that get us back to the original 2,000 feet of fencing? Yes, and you can also see why you would not want to round this to the nearest foot. Because if you did 167 times 6, you're going to come out with an extra 2 feet of fence, and he wouldn't have enough to do that. So it comes out just right if you round it to the tenth place, but anything that comes out to be like 0.66 repeating, 0.3 repeating, something that you can make a convenient fraction out of, like 1/3, 1/2, 2/3, even 3/8, which would be out to 3 decimal places. So that's the final answer. It should be a 500 that way, but then 166 and 2/3 up. The last thing is the 1 pin. What would the dimensions be of just 1 pin? If we have 6 going this way and it's 500 long, what's 500 divided by 6?
83.3 repeating.
So it'd be 83 1/3. 83 1/3 by 166 and 2/3. 83 1/3 by 166 and 2/3 would be the dimensions of the 1 pin.